All right, so let's take a look at the answers to your warm-up. Boop. They're a little tiny. Ugh, somebody's annoying. Put the caps on the wrong pens, the losers. Alex.
Why is it on revised? Why is it 4 months?
You sure?
That's fine.
Okay. Cool. Yeah, maybe a little bit too close. Holla if you got questions. Yes, ma'am. 5. You looked so serious with your 5. All right, so I'm going to assume that you got your center because it's right there. So you should have had x minus. Then that would have been where the problem came from. Yes, that would have been mighty confusing. That's why I usually, when I'm talking about covertices, if I'm abbreviating, I'll do CV. Okay? Anybody else? Wake up, Brian. You got this. Ooh, go. Yeah, take care of it. Ernebert. Are we liking these conic sections, or at least not hating them as passionately as you've hated some of the other units? Okay. She's like, yes! Okay. Well, you guys have the notes for today in front of you, so I would make sure that you have that. Yes, Jade? Because when we're doing this guy, we have that A is 6 and C is 9. For an ellipse, it's A squared minus B squared equals C squared. So that's 36 minus B squared equals 9. And yeah, still okay. Yeah. Do you see what we're...
Oh, I thought 36 minus 9 was 25.
It's the signs. Gotta watch them signs. You guys are silly. Anybody else? All right, because today is going to be extremely, extremely, extremely similar to the ellipses. It does tack on a few new pieces, but the general idea is the same. So what we're talking about today, anybody know how to say that word? Hyperbola. Yes. No, not right now. If we have time at the end of class, I'd be more than happy to, though. Okay. So what we're talking about today, these are the wrong notes, is a hyperbola. Now, a hyperbola isn't quite as easy to make as, for example, the ellipse and the circle. It's kind of this convoluted distance, random sum formula thingy. But what's nice about the hyperbola is we have some very, very similar features on the hyperbola that we would have had on the ellipse or on the circle. So we have a center, just like we did before. We go out equidistant from the center to find your vertices, just as you do before. In this case, you can't see it, but we do go out equidistance on the other axis, but that's not considered a co-vertice anymore. It's a very special point that ends up making a box for us, and the box is very important. And these points, we don't even really call them points. We call them the end points of our conjugate axis. Don't worry about that too much. We'll go over that. And then what happens is once you have that drawn, that box drawn, you can connect corner to corner, and those become asymptotes by which you draw your hyperbola. Yes, I see the crazy funky looks everybody's giving me. That's okay. Let's take a look at it just a little bit more straight on. I want you to examine these two equations. Compared to the ellipse, what is the same? It's equal to 1. The general setup of the top part. And even the bottoms are pretty similar, right? What's the biggest difference? Subtraction. It is the subtraction that makes this a hyperbola. One tiny little sign difference. And I want you to compare horizontal to vertical. How might I be able to tell that this one opens this way and this one opens up and down? The Y and the X switch. You look at whatever variable comes first. Whatever variable comes first tells you which direction your hyperbola is open. Or we call that which direction your transverse axis is. Which is a lot easier to say opens where. Okay? Now hyperbolas are very, very important creatures. They're actually all over the place in architecture and physics and design. If you think about the cooling plants for a nuclear cooling plant, you know, they've got kind of that shape to them that looks kind of like this. It maximizes cooling surface and still has a structurally sound form. So these guys have a lot of applications, and actually all of the conic sections play a huge role in calculus. Okay, so here we go. Let's see what stays the same and what changes between hyperbolas and ellipses. Guess what stays the exact same? The center. The center is still the same. No difference there. Okay? Now, if we look at what is under the X, that is how far we go out in the X direction. What is under the X is how far you're going to go out in the X direction, whether you see it there or not. What is under the Y is how far you go out in the Y direction. Whether you see it or not. So just like before, just like we had vertices and covertices, you're going to follow that same pattern here, and then when you figure out where those guys are, you're going to use those points to draw a box. Sometimes I only draw this corner, this one, and this one. Because technically, all you really need are the corner points. So if you don't want to draw the box, you don't have to. And then what you're going to do is you're going to draw from corner point to corner point a dashed line, because it's not actually part of your graph. It's the asymptote we use to draw our graph. Okay? We do the same thing here. Make your box, draw corner to corner. And just as we had in rational functions, these are our asymptotes. And the last thing that's similar but different for hyperbolas as it was for ellipses is where last point, the foci is going to be. It's a focus, multiple foci. Foci is plural for focus. And basically what you're going to do is you're going to find your C, And your C is going to go again in the same direction as your vertices, but they go beyond it because now this is what we're using. And tell me, how is that different from what we used to find the ellipse C? It was subtraction, now it's addition, and look at that. Just like I pointed out with ellipses, whatever this sign was, we changed it for here. Exact same idea. This is minus, so this is plus. Is it wrong on yours? Then yeah, fix it, please. Sorry. Now, when we talk about how we're going to be labeling these things, you can think about A and B as being the numbers under the X and Y. The big thing here is it doesn't matter which one is bigger or smaller. Okay? And I almost don't even like to flip it around. I just think square roots, just like we did with ellipses. And then I'd say, okay, the number under the X, I go in the X direction. The number under the Y, I go in the Y direction. Just like with ellipses. What becomes different once you find your C, you're always going to do C to whatever the first letter is. Okay, rather than the bigger one that we did with ellipses, C always goes to the first letter. And what that does is that gives us what we call the transverse axis, which goes from vertex to vertex. So if I give you that, remember just like we were talking about vertex to vertex on the ellipse, that's the transverse axis, cut it in half for A. Conjugate axis goes the other way, cut it in half for B. Okay, and then this is the equation of our asymptote. And all I'm ever going to ask of you is to leave it in point-slope form. Point-slope form is super, super sweet because all you're going to do is you're going to put y the opposite of the y, x the opposite of the x, just from your center. It's always y, it's always x, it's always plus or minus. And then m, what does m usually stand for? Slope. Slope is what over what? Rise over run. Which axis rises? The y. Which axis runs? So you're always going to look at your square roots, and you're going to put the one from the y on top, the one from the x on the bottom. And again, remember when we did the ellipses and I was trying to give you all the information at first, you looked at me like I was crazy? Like you always do? Because it's partially true? No, it's not. This is all going to come together in just a second. It's easier to do than it is to say. Ready? Ready to do? And it's like, nope, nope, don't like it. Let's do it. I don't care. Okay. Thought somebody died right there. I'm glad nobody did. Lisa's freaking out. Brian's doing the whole, what's that movie where the spins their head around? Poltergeist. Is it Poltergeist? No, it's Exorcist. Brian's channeling the Exorcist, spinning his head in circles. It goes to show that every day is every day in here. I don't act any different. Unfortunately. All right, so let's just randomly kind of think about what is going on here. What is this? Of an ellipse. Why is this an ellipse? Because there's a plus sign. What's this one? Hyperbola. Hyperbola. I'm just kidding. Hyperbola. It helps me spell it. Hyperbola. Hyperbola. All right. So that's the first thing that you need to figure out is what type of a conic section it is. If you have them equal to 1, as we have here, and you have two different numbers here, then it's going to be either an ellipse or a hyperbola. If either these two are the same, or there is no multiplier and it's equal to like just any other number, it would be a circle. Okay? So what I want you guys to do, I want you to go through and I want you to graph that ellipse. Please. And you will see that I've given you spaces to work out everything you need. No, there are no asymptotes in ellipses. Make sure you label all of your points below. Okefenokee? It's actually the name of a state park in Georgia, by the way. It's a giant swamp. They call it a park. Whatever. Odie, let's take a look. Ready? 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 Please plot the points correctly. The other class had a lot of folks accidentally plotting them in the wrong spot. How are we doing with the picture part? To me, I think when you're given the graph and you're asked to draw it, I think the picture is almost the easiest part because you don't have to sit there and try to calculate coordinates or anything like that. But you were asked to find those coordinates, so here they are. And by the way, I do not care which order these are in. Okay, purposefully flip them around from what we normally do, just to kind of make sure you understand. It doesn't matter which one of those you put first. How we doing? So far, so good? What did you just say? Did you compare me to Obama?
No.
What?
She was saying a song.
Oh, okay. I don't know. I'm sorry. But I'm in the mood for you guys. Allie's like, I'm going to throw up. All right. So let's see how this relates when we're doing a hyperbola. Okay, contain your excitement. I know this is the most thrilling thing you could ever imagine yourself doing. You've got it. All right, here we go. What is the first thing that we plot for an ellipse? Guess what we're going to plot first here? The center. Where is the center? -2, -1. Then, just like we did with the ellipse, we're going to say, what's the square root of this? What's the square root of that? And we're going to go under the x. So I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. Under the y, 1, 2, 3. 1, 2, 3. Are you okay? So far, it's literally the exact same thing that we did with an ellipse. Now here's where things start to change just a little bit. You can either choose to draw out your box. I really don't care. Or just draw the corners of that box. And then from corner to corner, draw your asymptote. Corner to corner, another asymptote. Should pass right through the center as well. And remember, whenever I give you a grid to draw your graph on, please fill the entire grid. All right, I need to make a decision with this though. Which direction am I going to open? Top to bottom or left to right? Left to right. Your x, that's the positive guy. X goes from left to right. That means my hyperbola is going to go from left to right. That means I'm going to have a point here, and your hyperbola always touches these guys. These are your vertices. And then it's going to kind of hug out towards the asymptotes. Touch the vertex, kind of hug out towards the asymptotes. Okay? Now, the mathematical part of what we just did, our center was the same. How do I find C? One more time. A squared plus B squared equals C squared. So I'm going to have 16 plus 9 equals 25. So what is C? 5. And it doesn't matter which one you consider A or B. It doesn't matter at all. Okay? Then we have the vertices. We don't have covertices. We're going to have endpoints of the conjugate axis. And we're going to have foci. Now, for the vertex, we're going to say which variable came first. X. So the vertex here is going to be done to the x-axis, or the x-coordinate, which means the foci will as well. Since x is the one that leads the way, it's positive. That tells me to find my vertices, I'm going to go in the x direction. Okay, it's not like where it was with an ellipse, where it was the bigger one and the smaller one. It's just whichever one comes first. And so that means the endpoints of my conjugate axis, or what we would have thought as our covertices, is the other one. So when I'm looking at this, my A is 4, and it's not because it's bigger, it's just because that one's the first. And so I'm going to add and subtract just like I did before. And guess what? They're the exact same points that I got before. Covertices, or endpoints of the conjugate axis, that's my B, so I'm going to be adding and subtracting 3, and surprise, surprise, those points are exactly the same. Are the foci going to be the same too? Correct, they are not. Because on the ellipse, the foci are inside. On the hyperbola, they're outside. So for my foci, I'm going to go 1, 2, 3, 4, 5, and 5 this way. There are my foci. So I'm going to add and subtract 5 to the x coordinate. Okay? The very last thing that we have to do here is our equations of the asymptotes, which always is going to be y minus the y coordinate equals plus or minus m x minus, wait, is h comma k, so this should be k, and this is h. So I'm just going to say y. What is the opposite of the y coordinate? What will go next to the y? 1. Thank you. Equals plus or minus. We're going to come back to the slope. What's going to go next to the x? 2. Beautiful. Just like it was up here. Right there. All right, now let's take a look. What were my square roots? 4 and 3. Which one went with y? Goes on top. Done. Lots of tiny little steps, but those steps in and of themselves aren't supposed to be too crazy. Cray cray. Yeah, I know, that's old and ridiculous. I said cray cray. He's in another one of my classes. Miles. Senior. So you wouldn't know, you're lowly sophomore, so I mean. All right. So how are we doing with this information? Yes, sir. The endpoints of the conjugate axis? Do you understand how I got it on the picture? Here and here. So it's as if when I were to draw an ellipse, that's where the covertices would have been. But with this, it's not actually a point on our graph. It's just the endpoints that help make that box that designs our asymptotes. Okay? A little bit better? Yes.
So for the equation, because the opposite would be 2, correct? That's...
Opposite would be -2. Oh, you're talking about to go from the center. I'm sorry. Which equation are you talking about?
The equations of asymptotes.
Okay. So we're looking down here.
Yeah. For x, when you wrote x plus 2.
Because it's the opposite. Opposite.
Okay. Because I was thinking of the equation.
Nope, and it's the exact same thing if you were to pull it straight from that equation.
Okay.
You get the same pieces down here. Okay? All right, let's go from a graph to an equation. Let's figure out some stuff. Where is my center on this number 1? 0, 0. Yay! What is this? What kind of a conic section is this? Hyperbola. And the reason why I'm writing that out is because that will tell me the general form. So I have a minus in between them. And I have it kind of set up like that. Now, which direction does my hyperbola here open? And which axis goes left to right? That means x is the first one, y is the second one. Okay? So A, well, center is 0, 0, so I can put either plus or minus 0, or for those of you who like to, you can leave that blank. I don't care. I like put the numbers in just to make sure I know I did it. So if I look at the graph, what is A? 3, because that is how far we go in the x direction towards my vertices. So what is going to go here? 9. Okay. What is B? 4. That's how far I go to the endpoints of my conjugate axis. So what is going to go here? 16. So that's really it for the equation, but it asks for some more things. We need to find the foci, so it means I need to find what C is. How do I find C? 9 plus 16, and the square root is 5. So C is 5. Am I going to go up and down or left to right? Left to right. So I'm going to go 1, 2, 3, 4, 5, and 5. There are my foci. And I'm going to add and subtract that from which coordinate to actually get the coordinates? X. Again, it's whatever one is first. So that means I'm going to have negative 5, 0, and positive 5, 0. For the asymptotes, it is always y, opposite of the y coordinate, plus or minus x, opposite of the x coordinate. So, what is the opposite of what's next to the y? So if you wanted to leave that blank, you could. What's the opposite of what's next to the x? Also 0. So now I need to find my slope. What is my slope going to be? 4 over 3. Okay? Is it not quite so bad as when I was trying to explain it? A lot of little things here, though. All right, so what I want you guys to do, start to finish on your own, I want y'all to do number 2. What? What? How dare I expect anything of you? Sure, sure. Back pedal. Back pedal. Pay very close attention to order and signs. Check your answer with your neighbor before I go over this. I want you to see if you can find each other's mistakes. Take a close look at the little things. Order, signs. Is that kombucha? Bull. It's like drinking vinegar. It's fermented stuff. It is good for your stomach and gut health. All right, now let's go back to the topic at hand, which happens to be conic sections, because we are in math class, not whatever else that would be. What? I will, but probably not until it comes out on DVD. I know. No, just... Oh, my Lord! You're all over the place. I don't know which of us is worse. I think it's you. All right, check your answers.
Wait.
What did you do?
Wait, what?
Oh, it's down one. Okay, sorry. I know how to count. I was like, wow, I did that wrong last time, but I didn't. So this should be 16. That should be 4. There we go. You dork. That's okay. I apparently can't count, so we're all good. I had it right the first time I did this. Dang it. Here. It did ask for all of that. I'm sorry? A and C are always going to be the same. Foci and vertices are hand in hand with each other.
Would you have to write x minus 0, or could you just do...
If you just want to write x, you're fine. It's just a personal thing for me, because I tend to look over things over and over again. And unless there's a number there, I think I haven't done it. Okay. So everybody got their center correct. You didn't accidentally flip those two around. Cool. I was worried about that.
So you do have a Twitter?
No, I do not have a Twitter. All right. So we've gone from some graph to equation. Now we're going from equation to graph. You know what? I just want to see what you guys can do. Go ahead and try number 3 for me. What? Give it a shot first and then whine. Okay, now I'm going to puke. I know. All right, guys, pay close attention again to order, signs, and yeah, usually it's helpful if you know how to count. That can be helpful. Shh. All right. Check your answers with your neighbors, please. Pay close attention to the little things, because it's all little things.
Oh, shoot. That's not all I did.
Oh my God, I love you guys so much.
You're right. Obviously. Why have these lines on everything? Why can't we just not drown?
Oh, you went the wrong way.
Yes,
Uh,
dude. And you would ask me if it was dummy sticker section.
See, that's wait, I just got it.
Imagine doing this on a test where you get the entire problem wrong, and you've already graphed it and everything, you just want to die. I don't even know.
no.
You just erase it all. Literally what you do, you have to erase it all.
Okay, ready?
No.
I'm like hearing the pain and the groans. And do you guys notice what I'm talking about when I say watch out for those little things? It is, oh my God, child, stop it. Stop calling yourself stupid. And I like need you to write on a piece of paper, I am not stupid, 100 times.
And then she'll be like, oh, I forgot.
Well, it's a math class, spelling doesn't count, so there. All right, so what do you think?
How do you justify where to put the close on?
How do you justify, okay, well, if I look at square root of 34,
34.
okay, what are the two closest, like one above, one below, perfect squares? What perfect square is bigger than 34?
5 and 6.
5 and 6. But it's closer to the 6, right? Because that's 36 versus 25. So I plot it closer to the 6 than I do to the 5.
That makes so much sense.
That makes sense.
Okay?
That's like common sense, actually.
Oh.
Wait,
Yes!
do we have to draw that like yellow arrow?
No, I did that for you. I did that for you. You don't need to. All right. Try number 4 for me, please. Please watch the little things. You're doing 4. You're doing good, guys. You got this.
Please.
I don't know why I'm like having that.
We're not going to... Yes, there is another side of this. We are not going to get through all of this today. That is okay.
No,
Oh, there's a hole in your graph. I thought you said there was a whole nother side. I was like, yes, there's... Haha, get it? A hole in the graph. He has a point. No, it wasn't. It was really bad. But thanks for the credit. All right, guys, come on. Let's focus again.
yes.
I apologize for the hole in your paper.
Oh my God,
And then how do you know where
Okay, let's. Elise, you are my queen of random. You do know that, right?
go back and listen to this recording just for fun. Just for fun.
Yes, you are being recorded. Thank you for noticing. All right, come on, guys. It's a beautiful day in the neighborhood. Oh, yeah. Shh. Come on, ladies and gentlemen. We can do this.
Oh, yeah. Yeah.
Your erasal pen just like in a ball. You're taking all the responsible icing that you can't erase.
Do not be dissing erasable pens. Mine are still better than his, but still. Mine are colorful. Shh. Okay, come on, guys. Wow. 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 Oh. What? The subscriber count? Yeah. The humor of it all. All right, guys. Come on, please. You done? Good. Oh yeah, that's the tricky part. That's the worst. All right, you can even see here that I got a little confused at first. I put it in the same direction I did last time, but the x comes first. So my transversal axis is the x-axis. I only hear things you don't expect me to hear. But I'm deaf when you're talking straight to me. No, afraid not. We still have, hang on, I will tell you. We have, what is that? Where did it go? So we have our units on continuity and behavior and limits left. So there's one more unit.
But is that like a good unit like this? Or?
I think there's like one section which is tricky, but you've done that one section before, which is graphing rationals. But the calculus part of it is going to make everybody want to take calculus because it's really not that bad. Alrighty. Questions on this? Jaden? Parabola. It's a little bit different than when we've done parabolas before, like we're tacking on some characteristics, but that's it. So you have circles, ellipses, hyperbolas, parabolas. Only 4. I'm glad you said only 4, not only 4. Okay. So, all right, take a look at this guy. Shh. Let's focus, please. Yep. We should be able to get at least number 5 in. Nick, what?
You used to live in Detroit.
Actually, I have no idea, and I'm kind of happy about that right now. All right, so take a look here. What is different about this than what we've seen before? The y is first, and what else?
I see.
The x squared is negative. In a hyperbola, one of your squares is going to be negative. Because that takes us right back to what we were looking at before. You see we have the negative in front of one of those pairs. So, use that as your starting off point. And what you're going to do is the variable that's positive is going to go first. The variable that is negative is going to go second. So let's reshuffle. So I will have 4y squared plus 24y. That's all of my y's. So then I'm going to do minus x squared plus 8x. And while we're at it, let's go ahead and move that 4 to the other side. Now again, this is very, very similar to what we did for ellipses. The only thing that's different is we now have that negative in front, and we've got to be a little bit careful with how we handle it. So, if I was just looking at this stuff here, what would you have done to complete the square? She's like going bloop, bloop, bloop. Take out the 4. So I'm going to pull the 4 out of the 2y terms, so I will have y squared plus 6y. I'm going to go ahead and leave a space there. Now, where you got to be careful here is when we pull out whatever is in front of this variable, we have to take the negative with it. I am pulling out a negative, and technically it's just a 1 there. So you can write it or not, it's up to you. And when I take my negative 1 out, what will this stuff become? X squared minus 8x. Again, I'm going to leave a space. When we complete the square, that's where we put stuff. So when I complete the square, I'm going to have square root. What's going to go here? Plus 3. What is 3 squared? 9. But what did I just put into my equation? 36. So if I put in 36 on this side, I need to do it on this side as well. And that's because there was that 4 out in front. When I look at the next part, I'm going to do square root. What's going to go here? Minus 4. Squared gives me, what did I just put into that equation? So I've got to do a negative 16 over there because there was a minus sign out in front of all of that. So what do you got? Negative 4, negative 16, positive 36. What's negative 4 and negative 16? Negative 20. Oh, yeah, sorry, I wasn't thinking. And negative 20 plus 36 is 16. It's okay. We all have moments. It's all right. All right. So what conic section is this? Hyperbola. So what does a hyperbola have to be equal to? So how do I make that happen? Four goes into 16. 4 times, Brooke's like, dar. Come on, Augsburger. 4 times. So there's the equation of my hyperbola. The graph's the easy part. You've got it. You've got this. The graph's the easy part. For example, where's my center going to be? Ooh, careful. 4, negative 3. Remember those little things like the order? X, comma, Y. It's holy biscuit. You guys are hilarious. All right, so 4, negative 3. Then which direction is this guy going to open? Up and down, because it is the Y that comes first. How far do I go out in the Y direction? 1, 2. 1, 2. How far do I go out in the X direction? 1, 2, 3, 4. So then we can draw our box or our corners, whichever one you feel like doing. I used to always do the boxes, and then I was like, shh, ain't got no time for that. And again, when you have a graph provided, fill it. Now we've already stated the graph is going to open up and down. So my vertex, and again, you have to touch that vertex. It goes through that point, not just close to it. You get close to the asymptotes. Okay, and I'm missing one thing. What am I missing? foci. How do I find C? A squared plus B squared equals 20. What is the square root of 20? It is going to be between 4 and 5. And how do you simplify that? 2 root 5. Okay? So that means I'm going to go between 4 and 5. It's pretty smack dab in the middle there. 1, 2, 3, 4, and 5. And there are my foci. Yay, math! See, look, even next door thinks it's awesome. It's perfect timing there. Well, it's not that close. Geez, guys, you got 6 minutes. What are you... Alex, shut up. Ooh, it's almost time to go. No, it's not. Oh, my Lanta. I blame Alex. It's all on him. Okay. Huh? Yeah, sure. Yeah. A pre-calculus lesson is going to be trending on YouTube. Okay, whatever. You're delusional. All right, so we're not really going to have time, I don't think, to get through problem number 6. So let me kind of skip you to what the homework is going to be. And I'm going to narrow down the homework a little bit for the stuff that we haven't quite gotten to.
Do that much?
Yes.
Or just 19 and 21.
Do those. Okay? Because that's going to focus on graph to equation, equation to graph, and finding the standard form given expanded form. Now, I do want to kind of take a second and discuss how class is going to go next, because things get a little funky. And I know that I'm going to be missing folks for various AP exams and SOLs coming up. So I want you guys to understand, on Wednesday, I am going to have, that's not you guys, okay. Wednesday, we're going to be finishing up hyperbolas and starting parabolas. Okay. On Friday, we are, let me see here, where is everything? On Friday, we're going to finish up parabolas and start our review. Tuesday of next week is going to be your test. We're not going to be missing too many people. Test on conic sections. Okay? And if you are going to be absent, please remember, for any of these upcoming days due to SOLs or AP exams, what am I doing? Posting what? Videos. Where can you find those? Ogs Vlogs. Yeah, give me 1 second. Let me make that thingy go away. Done.